Corporations pour billions of dollars into enterprise artificial intelligence, expecting immediate operational efficiency. Yet, when you measure actual usage on the front line, adoption rates flatline. There is a massive disconnect between boardroom expectations and the reality of execution. This failure happens because most AI systems are designed for a theoretical version of work, rather than the environment where the work actually takes place. We call this designing for work as imagined. Work as imagined is the sterile, perfectly linear world of the standard operating procedure. In this model, every ticket is routed cleanly, every asset has a perfect maintenance history, and every step is completed in exact sequence. That stands in direct opposition to work as done. Work as done is the messy, physical reality of the front line. In this environment, technicians deal with missing asset tags, overlapping radio calls, outdated manuals, and intense pressure to get a stalled production line moving immediately. Executive leadership often operates with a critical blind spot. They treat the standard operating procedure not as a guideline, but as a literal behavioral description. The distance between that official documentation and the actual execution on the floor is known as process debt. It is the accumulation of every hidden workaround, undocumented peer call, and skipped administrative step required to actually do the job. When you deploy an advanced AI model against that brittle, idealized standard operating procedure, you do not solve the operational friction. You isolate the tool from reality. Automating a flawed workflow means paying for premium compute power to scale your process step faster. To prevent this failure, workflow mapping cannot be treated as a compliance checklist. It must be treated as a forensic extraction of the truth. To understand that truth, we have to isolate the moment of work. This is the exact split second a technician stands in front of a failed system and must make a critical decision. This moment is defined by severe constraints. The environment is loud, the available data is incomplete, and the clock is running. The stakes are entirely physical and financial. If a Tier 4 data center cooling system fails, downtime can cost $10,000 per minute. Technicians do not have time to explore software. Yet official enterprise tools regularly introduce friction precisely when speed is most required. They demand multi-screen navigation, complex logins, and mandatory data entry fields before offering any useful guidance. Faced with this, the frontline worker does what any rational operator would do. They bypass the official system entirely. They reach into their pocket, pull out their personal phone, and use unofficial channels to get the equipment running. Bypassing a multi-million-dollar AI rollout is not an act of frontline rebellion. It is an intelligent defense mechanism. The technician is protecting operational performance from unacceptable cognitive load. To capture exactly where that cognitive load occurs, we use a tool called workflow decomposition. We break the execution down from A to F to separate the fiction of the process from the reality of the floor. Take a baseline scenario. A high-speed packaging line shuts down. According to the manual, this triggers a strict 14-step recovery sequence. Here is how that actually plays out in our matrix. We start with step A, the trigger. The official process claims the workflow begins when the dashboard registers an alert, but in reality, the operator heard an anomalous grinding noise minutes prior. For step B, the initial action, the documentation requires the technician to log into the corporate diagnostic app. Instead, they physically inspect the belt and start a WhatsApp video call with a senior peer. That informal peer network, operating entirely outside the view of IT, is the true diagnostic engine of the facility. If your AI model is trained strictly on the SOP, it misses these initial steps entirely. It is already blind to the cues and knowledge networks that actually solve the problem. Moving to step C, decision points, we hit the bottleneck. The technician must determine if the vibration they are feeling is a catastrophic bearing failure or just normal wear and tear. This interpretation is the highest point of risk in the repair. It relies entirely on human judgment, creating intense psychological stress. To make that call, we reach step D, information inputs. The technician needs specific historical context about this exact machine. The official enterprise app requires 12 distinct screen taps to locate the asset history. Because that takes too long, the technician relies on their own flawed memory of what happened during maintenance 3 months ago. The mental effort required to navigate poorly designed digital tools while simultaneously diagnosing physical machinery under extreme time pressure is known as cognitive load. At the precise moment the worker requires absolute clarity to prevent a failure, the official system demands interface navigation. The software itself induces behavioral failure. This leads to step E, workarounds. The technician completely abandons the official diagnostic kiosk. They stabilize the packaging line using their personal experience and undocumented peer advice, executing fixes that the central system cannot track. Finally, in step F, the outcome is achieved. The physical production line is running again. Only after the crisis is over does the technician return to the device to pencil whip the required fields, fabricating a sequence of events to satisfy the compliance software. The actual informal repair took 4 minutes. The official required procedure would have taken 12. That 8-minute gap quantifies your process debt. Executive dashboards across the organization ingest that fabricated 4-minute record. Leadership looks at the metrics and sees an illusion of perfect operational control. This creates severe data poisoning. The system records an abandoned, theoretical sequence as a successful repair, cementing a lie deep into the historical database. Any machine learning tool deployed on top of this foundation will learn exclusively from these operational fictions. You guarantee that your AI will output technically plausible, but operationally absurd recommendations. To break this cycle, organizations must rebuild the workflow entirely, moving toward a state of intelligent operations. The strictest rule of this redesign is simple: you must never automate a broken process. Digitizing a useless manual 10-field form into an AI-powered 10-field form yields zero operational value. Instead, apply the kill the form rule. Strip the workflow down to the absolute minimum standard of care, eliminating redundant approvals before AI is introduced. Once simplified, the technology model shifts. We replace manual, query-based searches with push-based intelligence. Instead of making a technician search for a fault code, a connected sensor pushes a single, likely failure condition directly to their wearable device. The ultimate operational value of artificial intelligence is not to replace human judgment. It is to protect that judgment by ruthlessly eliminating the friction that surrounds it. For that friction-free system to take hold at the front line, it requires a behavioral engine. We call this the trust loop. It starts with suggestion. The AI pushes context-aware, grounded guidance directly into the moment of work. Next is validation. The human technician reviews the AI's logic and confirms it matches the physical, real-world conditions they are standing in front of. Phase 3 is the outcome. The combined human and machine decision works, successfully dropping the mean time to repair. Finally, reinforcement. That proven success creates the psychological safety required for the worker to default to the tool the next time a machine fails. This trust is intensely fragile. A single absurd recommendation generated under high pressure can permanently shatter this loop, sending the technician back to their shadow workflows forever. You cannot achieve adoption by mandating it through corporate policy. Trust at the frontline must be engineered, earned, and repeatedly validated. The organizations that capture the next wave of enterprise advantage will not be the ones that purchase the most AI licenses. They will be the ones that design the best workflows for AI to operate within.
For more insights, subscribe to Purposeful Nudge and start rewiring your field services organization today.